Before starting the topic, we need to know the topic reflection of light and terms related to it. Reflection of light can be defined as when a ray of light enters from one medium, falls on the surface of another medium, it bounces back into the first medium such that angle of incidence is equal to angle of reflection. Suppose a ray AO is incident upon a mirror, and after striking the mirror it bounces back to the medium air as OB. If ON is normal drawn to the mirror, then angle AON is equal to angle I and angle BON is equal to angle R, such that angle of incidence is equal to angle of reflection. Now we explain the reflection of waves. Place a barrier in a ripple tank. The straight waves after striking will bounce back as shown in the figure. Now if the barrier is placed at an angle to the wavefront, the reflected waves will obey the laws of reflection. This figure shows the reflection of waves before reflection, and second figure shows the reflection of waves after reflection, such that angle of incidence is equal to angle of reflection. So we can define reflection of waves as when waves move in one medium, fall on the surface of other medium, such that the angle of incidence is equal to angle of reflection. This is called reflection of waves. The numerical 10.7. According to the statement, a transverse wave produced on a spring has a frequency of 190 Hz and travel along the length of the spring of 90 meter in 0.5 second. We have to find what is the period of the wave, number 2 what is the speed of the wave, and number 3 what is wavelength of the waves. For solution, we see that given frequency is 190 Hz and distance traveled by the wave is 90 meter, while time taken by the wave is 0.5 second. We have to find number 1 time period, number 2 speed of wave, and number 3 wavelength lambda. For solution, we use formula T is equal to 1 over F as the relation between frequency and time period is reciprocal relation. So T is equal to 1 by F. By putting values, we will get as time period is equal to 0.01 second. Number 2, to find speed of wave, we have formula V is equal to S over T. By putting values S is equal to 90 and T is equal to 0.5 second, we will get velocity is equal to 180 meter per second. And for finding wavelength lambda, we have formula V is equal to F lambda, and lambda can be explained as lambda is equal to V over F. By putting values 180 over 190, we will get 0.95 meter. 10.8. The statement of this numerical is water waves in a shallow dish are 6 cm long. At one point the water moves up and down at rate of 4.8 oscillations per second. We have to find what is the speed of water waves, and number 2 what is the period of the water waves. 4 point oscillations per second, actually it is frequency of the wave. Here given wavelength 6 centimeter. By converting into meter, we will divide 6 by 100 and we will get 0.06 meter. Whereas frequency is 90 oscillation per second or 90 hertz. To find is speed of waves and number 2 time period for the wave. In solution, by using formula V equal to f lambda, by putting values of f and lambda, that is 4.8 into 0.06, we will get 0.929 meter per second, and time period and frequency is t is equal to 1 over f. By putting values of frequency 1 over 4.8, this will equal to 0.21 second. So velocity is 0.29 meter per. In numerical number 10.9, we have statement: at one end of ripple tank 80 cm across, a 5 Hz vibrator produces a wave whose wavelength is 40 mm. We have to find the time waves need to cross the tank. In this numerical, given is number 1 distance, which is 80 cm. By converting 80 centimeter to meter, we will divide it by 100 and we will get 0.8 meter. Frequency is given 5 Hz and wavelength is given 40 millimeter. By dividing 40 by 1000, we will get 0.04 meter wavelength. What we have to find is time taken by the wave to cross the ripple tank. In solution, we have formula V is equal to f lambda. By putting values of f and lambda, we will get wave speed is equal to 0.2 meter per second, and we have formula V is equal to s by t, which can be changed into t is equal to s over v. By putting values of s and v, which are 0.8 and 0.2, we will get time is equal to 4 seconds. This is our required